Hello everyone and welcome to our first lesson of the semester. We are going to be starting out checking out functions and all the things that come with functions. At the beginning of every lesson you're going to see the section title here. I don't want you to pay too much attention to that just because that's just dependent on the textbook that we are using. So right now, this is the 3.1 section in the textbook that we're using this semester, but later on in some other videos, I may have a different section title at the top because I might have been using a different textbook at that time to pull examples and whatnot. So just be aware, I'm going to save this video, this lesson video, based on the section that it lines up with, so you don't have to worry about where it comes from. You just look at the title. The other thing I want to point out to you is that at the beginning of every lesson video, you're going to see in red typically something that's abbreviated as LT. Those are our learning targets, meaning that is what we are trying to target and what we are wanting to learn or have been introduced to and to practice working on after this lesson video. So our learning targets for this video are, I want to be able to determine if relations between two items or two variables are actually functions, which means we're going to have to talk about what's a relation and what's a function. We want to identify independent and dependent variables. We want to determine the domain and range, and then use function notation to evaluate functions. So by the end of this lesson, by the end of this section of notes, we will have covered how to do all of these learning targets. So to start us right off with that first learning target, determine whether relations between two variables are functions. Well, before we can determine anything, we need to identify what a relation is and what a function is, and then we can compare and contrast them. So the official definition of a relation is a correspondence between two quantities, aka there's some kind of relationship between two things. And now, so we see that very often or all the time in our day-to-day life. Apples to oranges. Those are related because they are fruit. Dogs and cats, they're related because they are a type of pet. In math, we usually see it as formulas or equations and the coordinate points that show up, or a table of values maybe. The other word that's in that learning target is a function. Okay? A function is a relation that has a unique x and a y value. Okay? The x's are called the domain and the y's are called the range. Note the x's and y's don't have to be one-to-one. We'll talk about one-to-one later on at the very end of today's lesson, but I really want us to focus in on the definition of a function. Reading those words is a relation or a set of points that have a unique x and a y value. That may be a little overwhelming to some of you, or it may not be enough detail for some of you to really understand that definition. If we broke it down or if we wrote it out in our own words, it would just mean we don't use x values on repeat. We won't have a repetition of x values in a set of points. If you take a look at this chart here, you'll notice that. Over here are your x values and over here are your y values. Notice that every x value is unique. I don't use it more than once. However, even though the x values are only used once, in this area you'll see that a y value is used twice. That is completely fine for you to have occur and still be a function. Okay, so maybe in your notes, because what I don't want you to do is to copy word for word what's on my slides, because if they don't make sense to you, then copying them down in your notes may not be very beneficial for you. So maybe what you want to write in your notes is that a function has a unique x value and a corresponding y value, or in a function, the x values never repeat. I never use an x value more than once. Okay? Pause this video. I'm going to cue you with that or prompt you to pause the video and jot down notes throughout the semester, but I also want you to get in the habit of anytime you need to pause the video, pause it. It's not going anywhere. Pause it, jot down some notes, or maybe jot down a question, and then you can resume the video, or you can rewind the video and watch something again. So go ahead and pause the video and jot down your definition of a function. So as we already referred to the x and y values up here, and I think that we all are familiar with that. If not, then we've got some issues. I'll see you during office hours. One of the most basic things you probably remember learning in high school math are the x values and the y values, and maybe graphing them. Maybe something else you remember is that there are other names for the x values and the y values in a table or in a coordinate. So let's look at a couple of those names. Again, pause the video whenever you need to take some notes, because I'm going to go right through it so I don't have a super long video because I'm pausing for notes. Okay. So several other names for the x value or the variable x. It can be called the domain. The domain is the set of all x values. Okay. We can also refer to the x values as the independent variable. Okay. If something is independent, that means it stands alone. You don't have anything that prompts it. It comes first. It is the first thing that comes. Nothing else. It doesn't depend on anything else or rely on anything else for it to occur. So your x values, if they are independent, think of them as a strong, independent individual and how you would describe that individual. Unique, stand alone, they don't need anybody else. The x values are the same exact way. They don't need anything else. They can exist on their own. Now, the y values can be referred to as the range. The range is the set of y values. They are also referred to as the dependent variable. If you describe someone as a dependent, like if you have to do your taxes or your parents are doing taxes and they claim you as a dependent, that means that in some level you depend on them in some way. You rely on them. You lean on them. Without them, you don't happen, kind of thing. Literally. Q biology class. We won't go there. A y variable is dependent on the x variable for its behavior. Okay? So we can't go graph a y value without an x value. The x value has to come first, then the y value. And so here we have on this next slide, I've got two examples for you to check out. And I just want to know if each of these examples is a function. So I've got them labeled as question B and question C. One of those is a table of values. The other one is a graph of some points. And so I wanted you to see in a couple different avenues or a couple different visuals some relations, and then determine if they are a function. So pause this video, jot down these two examples. You'll see that the answers are already up there, but I want to see if you can determine those on your own. Can you describe them on your own? So in the first example, that example B, you'll notice that we've got the input or output. So there's another type or another name for the x values and another name for the y values. So you may want to add those to your notes. Okay? But when we look at the x values, we see 2, 2, 3, 4, 5. An immediate red flag to you should be there's a repeat of x values. If there is a repeat of x values, then this is automatically not a function, which is why that answer is down here. Now, your explanation may vary from person to person. You may say there's not a unique x value to every y value. You may say, no, it's not a function because there's a repeat use of an x value. Or you may word it as it's not a function because 2 is used twice for an x value. however you want to phrase it, which you need to work on because on your test you're going to be asked to write that out in words, describe or explain your answer. Okay? This is definitely not a function. Okay? Part C, if we look at this graph, we'll see that there's not a repeat of x values. If that's hard for you to see, then maybe you want to actually write out those coordinates and their locations. So this one here is at 2, 3. We have another point at 1, 0, 0, -1, -1, 0, and -2, 3. So maybe you wanted to list all those coordinates out vertically so that you can see there is no repeat x values. So check, this is a function, and then you need to explain why you think it is a function. There are no repeat x values. Yes, it's a function because every unique x has a y value. Every input value is uniquely matched to exactly one output. However you want to phrase that wording, just make sure that it corresponds with the definition somehow, but use your own words. You don't have to use my words. I've been doing this much longer. I come from a different background than you, so I want you to use the wording that makes sense to you but is backed up with the definition of a function. Another way, a very easy way that you can determine if something is a function is called the vertical line test. This may be something that a lot of you remember because it's very easy. It's one of the easiest things that we learn in math class, but it's also one of the most useful. The vertical line test is exactly how it sounds. If the graph of something is a function, then it will pass the vertical line test, meaning if I take a vertical line and I draw it anywhere on this graph, if it hits that graph more than once, then it is not a function. If it intersects the graph more than once anywhere, then it is not a function. Okay? So then the inverse or the inverse or the converse of that statement would be if a vertical line does hit the graph at exactly one place at all times, then it is a function. Okay? So pause this video, jot this down in your notes, and go ahead and just do a rough sketch of these graphs as well for your notes. So number one, is this a function? No, it is not a function. Use your own words to explain it. You could very easily say no because it fails the vertical line test. It intersects the graph in more than one spot. On the vertical line, specifically, the vertical line intersects the graph in more than one place. Okay. So question 2, is this a function? Okay. Yes. Why? Because it passes the vertical line test. Yes, it's a function because every x value is unique to a y value. Yes, it's a function because it has no repeat x values. So on and so forth. Third one, draw your vertical line. Is this a function? No, it is not a function. Why? It fails the vertical line test. It does not have a unique x value for every y value. There's a repeat use of x values. Again, whatever wording and justification you want to use, go for it. Just make sure that it's backed up by the definition of a function. Okay. Lastly, is this fourth one a function? Yes, it is. Why? My answer is going to be it passes the vertical line test. Okay. All right, the second half of our notes is going to refer to function notation. So check out our learning target before we go any further. We have covered how to determine if relations are functions. We have discussed independent and dependent variables. We haven't done domain and range yet, but if you have looked at your course calendar, you will notice that we're going to be in this section for a couple days. So we will cover domain and range maybe next class. Okay? The fourth part of our learning target is use function notation and evaluate functions. So we're starting to cover that learning target already. So we've made some leeway. We've covered a good bit of ground today. We're going to finish up fairly quickly because I want to slowly ease you into content. Okay. In algebra, it is common to represent functions using equations or formulas, and those formulas or those equations almost always have two variables, and they are almost always the x variable and the y variable. If they are not using the x and y variable, then we can almost always interchange what's given to us for an x and y value. Okay? So, for example, the equation y equals x squared. This is a function, okay? This is also an equation involving an independent and dependent variable, or an input and an output. One of the things that I want to address, you're going to see it for the rest of this course, so we need to make sure that we understand it, is this. Oftentimes, we are used to seeing a table of values like x and y. And then we list our number, our x value, and then the y value, or we plug in the x value to the function, and we get out a y value. Okay. One of the things that I need you to acknowledge, or I need you to understand, is this. When we start dealing with functions, they are not always written as y equals yada yada. In this case, y equals x squared. Sometimes they are written as the function of the variable x is x squared. Please hear me when I say that the f of x and the y can function interchangeably. The f of x is the same thing. It's acting as the same thing, meaning if I plug in this x value, what comes out is going to be the y value, or the function of x value. So if I plugged in 2 to this function or this equation, 2 for the x value, well, if I plug that in, it would be 2 squared. 2 squared is 4. That would be the y value, or what f of x equals when I solve that out. The way that we would write this, and we'll get into this a little bit more in a further or a later lesson, but I'm just trying to front load you a little bit here. Okay. If I want to rewrite this equation in function notation, this is what it would be. And then if I wanted to plug in 2 for the value of x, I would write it in the place of x. And then solve it, which would give me, when x is 2, aka f of 2, that will equal 4. Okay, just kind of front loading you with that. That is a review of Algebra 1 and pre-algebra, so that's nothing new, but I just want to remind you of that. Okay. And again, we'll get into that more heavily and more deeply in a lesson later on, but just sharing that with you now. What's important for today is knowing function notation will allow us to also determine if something is a function algebraically. Okay. Meaning, say I give you this, okay, instead of a graph. Okay. If I give you a graph and I say, is it a function, that's easy because we remember the vertical line test. But what happens if I only give you an equation or a function? Well, you don't have a picture to determine if it's going to pass the vertical line test or not. You don't have that picture. However, if you have an equation, you can get a graph, right? Okay. If you have a graphing calculator, you should remember this. If you want to graph something, what do you hit? You hit the y equals button, and that's pretty universal for every calculator. You either hit the graph or the y equals button. Okay. So why does function notation matter? Or why does knowing how to write a function matter? Well, if I give you any function out there if you can solve it for y equals blank, 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 then that means you can graph it. And if you can graph it, then you can use the vertical line test to determine if it is a function. So I could give you something crazy like, let's see, x cubed minus y equals 71. Okay. Now I'm not asking you to solve that right now. What I am telling you is that if you solved that equation for y, if you got it in the format of y equals ... then you can graph that either by hand or by using your calculator, and you can tell if it's a function by using the vertical line test. Okay? And so that is how we're going to pretty much wrap up today's class, is by practicing that. So here are two examples for you. Okay? Determine whether each equation represents y as a function of x. All that means is this a function? Could I rewrite this function as f of x equals blank, blank, blank? Will it pass the vertical line test? Does it have a unique x for every y value? Okay, so what I want you to do, I want you to pause this video. I want you to do exactly what we just looked at, solve each of those equations for y, and then graph them to see if they are a function. Okay, so go ahead and pause this video and see what you come up with. So in order to determine if each of these equations is actually a function, we need to somehow, some way, solve both of these equations for y so that we can graph it and see if it passes the vertical line test. Okay? So here's your first one, part A. Okay? And let's check it out. Okay? So for part A, if we want to solve that equation for y, okay, this is why I put in some of those review questions for you for homework from our first day of class. We need to review this. Well, I'm not going to teach you this. Okay, so we're going to go through this quickly. In order to solve something for y, that means everything else over here with y needs to go to the other side. Okay, and the only way that I can get all of that to the other side is if I subtract x squared. And so that's what has happened here. I subtracted the x squared and I got it over here to the other side so that y is isolated. Now with this question, with this equation, I'm done, because on the left hand side I've only got y equals, and then everything else is on the right hand side. And so y equals 1 minus x squared. Okay, so if you were to graph that, okay, what would you get? Okay, this is just a very rough sketch of that graph, but here's what it would look like. I just pulled it up on Desmos and put a rough sketch on there, okay, because that's all I need, because when I see a rough sketch of this graph, meaning I didn't have to plot all the major points, I've just got a good visual and location of it. If I try to drop vertical lines everywhere on this graph, the vertical line only hits the graph once. It passes the vertical line test. So that means that y is a function of x, aka I could rewrite this as f of x equals 1 minus x squared. Okay, so then what about our second one? Okay, if we go to check out our second one, here it is. We still want to solve it for y. We want to have it so that it says y equals blank, blank, blank. Okay, so again, same thing. Everything over here, everything besides the y needs to go. Okay. And I've got an exponent that I have to deal with as well, but we have to make sure we cover things appropriately. So first, we want to get rid of that negative x, and the way we get rid of it, the way we move it to the other side, is by adding it to both sides. There it is. And then when we have y squared equals blank, 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 the only way that we can undo something squared is if we take the square root on both sides. And when we take the square root on both sides, it's a positive and a negative answer. Okay. And again, that's just some review from pre-algebra, algebra 1. Now that we've got this equation, what does the graph look like? There's my rough sketch. Again, I just pulled up Desmos on my phone to get a quick picture of it. You could also plug in some x values and y values on paper and then plot those points if you've got the time for that. But regardless, here's a rough sketch of the graph. If I start drawing vertical lines, what do you automatically notice? It fails the vertical line test. So this is not a function of x, meaning I could not rewrite this as f of x equals plus or minus 1 plus x. I would not be able to rewrite it like that because it is not a function. Okay? Now, the very last thing, this is the last slide and we are done for today. The very last thing that I want to talk to you about is a one-to-one function. Now, this was mentioned earlier in the definition of a function, and I told you we'd get to it at the end of today's lesson. Here it is. A one-to-one function is a function that has an exactly one output value to exactly one input value, meaning there are no repeats of any values. Every x value is unique and every y value is unique. Now, that's only if it is a one-to-one function. Only is it a one-to-one function. Make that definition make sense. One-to-one function. One unique x value matches to one unique y value. How do you determine if a function is one-to-one? So keep in mind, if it is one-to-one, it has to be a function already. Okay, so relation. Some relations can be functions, and some functions can be one-to-one. That's your process down. Okay. How do we determine if something is a one-to-one function? Using a horizontal line test. So it works the same exact way as the vertical line test. Here's a graph. Here's a function. Draw a horizontal line. Is this graph one-to-one? Is this a one-to-one function? We know it is a function because it passes the vertical line test. But is it one-to-one? No. Why? Because it fails the horizontal line test. Okay. Here's another one, and then we will be done. Is this graph, this blue graph, is it a one-to-one function? So first of all, is it a function? Yes, it is, because it passes the vertical line test. Is it a one-to-one function? Does it pass the horizontal line test? Okay. And the answer is yes, it absolutely does. Okay. If you want some more examples of that, then you can come right over here and look at these visuals in the very, or back up a couple of slides, and we can determine all of these things. So first of all, this is not a function, so it can't be one-to-one. This was a function. Is this second one a one-to-one function? Does it pass the horizontal line test? Okay. And the answer is yes. Yes, it is. Okay. This was not a function, so obviously it can't be one-to-one. Is this a function? Yes, it is. This fourth one? Yes, it is a function. We already have that in our notes. Is it one-to-one? And the answer is yes. Why? Because it passes the horizontal line test. Ladies and gentlemen, that is all I have for you. Check out your homework on the course calendar link. Remember to click the link for your course calendar because that's the live document that I'm constantly adding or changing. If you only look at the one in the syllabus, you might be doing a lot more work than what I've assigned because I've already changed that. I already adapted the homework for section 3.1. I shortened it. I made it a little less complicated. So please make sure you click the course calendar link, and that will take you to the updated homework. Okay? Make sure you show your work and ask any questions during office hours. And if you are going to be showing up for office hours, please send me an email or a remind message so that I will be fully present and available for you. Other than that, that is all I have. Have a good one, and I will check in with you soon.